Hi, today we'll be talking about functions. So, what is a function? It's similar to a function in math or anything you've interacted with. In Python, a function is just a group of code that you can reference very easily. So, um, in math, you might see like 2x plus 3, right? Or f of x equals 2x plus 3. We can reference this very easily by simply writing f of whatever value we want to calculate, and we know that we will just be plugging in 5 into this function. Similarly, in a Python function, we write out the group of code that we want to execute, and then we simply need to refer to the name of the function and whatever we want to input into the function, and we can do that specific thing that we want to do. There are many already built-in functions in Pythons that just make your lives easier. For example, there's the sort function, which I will show you an example of. So a sort function essentially just sorts a list in alphabetical order. And normally this might take a bunch of many lines of code, but since we already have a function for sorting, we can just reference the sort function and it will sort our list in one line. So essentially, use functions when you don't want to repeat, you don't want to actually repeat um, those lines of code like many times. That's essentially what the function of a function. So, for example, we have a list that is apples, cookies, bananas. Obviously, this list isn't in alphabetical order right now, um, and we want to sort the list. So we use the built-in dot sort function, and what this does is automatically sorts the list, and you see we don't have to write like a bunch of code that would actually be what um, is sorting the list, and we can simply just print the list now, and it should be sorted. Yeah. So next, let's go on to defining our own function. So the most basic function is just a function with one input parameter, and what that looks like and how you define a function is using this syntax. So you first write define, which indicates that you're defining a function, and then the name of your function. So we're going to be looking at a biology example where we want the A and T percentage in a DNA strand. So I'm just going to call it get AT content, and our input parameters is um, in the parentheses. So this is what we want to modify um, with our function. So obviously we want to get the AT content of the DNA. So, and then for a function, you always have to include these colon. So because everything under the function will just be what you're actually performing with the function. So for this specific function, we want to find the percentage of A's and T's inside the DNA strand. So you don't have to worry too much about this part, but essentially you just have to find the length of the DNA and then count the number of A's, count the number of T's, and then divide the number of A's and T's added together by the length. So that is quite simple, and it is what I am going to do right now. And then we can just and now we have the AT content, which is what we want, which is just the percentage of the A and T's added together. And then now, to end the function, we want a return statement. So what a return statement does is it tells you what the function is outputting, meaning what is the function actually getting like as a result for us. So it's kind of like in a sense like what you're going to print if you call the function and then print it. So Here we want to return the AT content, but in this case, for this specific case, I'm just gonna have the AT content rounded because I don't want like a super long number. Oh, normally you could just write return AT content, and when you call the function, this is what it will output. So this AT content. However, I'm just using the round function because I want the numbers to be shorter. So this rounded to two significant figures. That is what it means. And now to actually check whether our function works and to call it, we just reference the function name, except we use a more specific input. So what this means is that let's say we want to do it on a certain DNA strand, right? Not just like a variable. Then we could type the specific DNA strand inside here, like that. What this does is it just uses the function on this DNA strand, this input parameter. So now if we printed this, we should get, oh, whoops, 0.57. So that is the percentage of A's and T's in this DNA strand. So if we count, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ATs, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we have 21 total base pairs. So there are, and that comes out to be 57% A and T, which is what we got here. Thank you for coming to part 1 of functions. In the next video, we'll be talking more about more complex functions.